Here we have two full duplex radios that are identical to each other, in the sense that each of them can send, the other one receives, and the other one sends, the first one receives. This is the first radio, and this is the second radio. They are now simultaneously sending signal to each other over the same time and the same bandwidth. Each radio has an antenna that is designed such that the waveguides are designed in a very, very innovative way, in my opinion, that the signal cancel to a large extent within the antenna. Now let's look at what we have on the screen of the computer. We will display these graphs a few times. In full duplex wireless, what matters is that the signal that we transmit has a huge echo, maybe 120 times dB more, which means 10 to the power of 12 times more of transmit signal will get into the receiver and will saturate everything. The questions are, how can we cancel this? And the cancellation should be such that at the end of the day, the noise figure of the system doesn't degrade. Companies like, Como or others that they talk only about cancellation, they don't talk about noise figure. What matters is that at the end you reach to the thermal noise floor. Now let's see what are each of these curves. This purple one is the coupling that we have between the two terminals of the antenna, and we are transmitting at 10 dBm, and this is because the university regulation doesn't allow us to send more. As you see, antenna on its own has a cancellation of 26 or 27.6 dB. Then we have a single stage of a single filter, analog filter, and sometimes it cancels more, sometimes it cancels less, but on the average has brought the cancelling maximum of 14 dB and then 9.4 dB. Then after this cancellation, the signals are weak enough such that we can take them inside A to D. And that red line is the cancellation at the IF. And as you see, the red line has brought it from -20 to -80. So 60 dB total in these three stages. Now here we have two lines, that these two lines should be very close to each other. The black one is supposed to be the thermal noise floor. However, since we are working in the 2.4 gigahertz and Wi-Fi contaminates this band, we never get, you see that there is maybe a 1 dB difference. That last curve is the one that after we have done the cancellation at the IF, and as you see, a total cancellation of mean of 109 and maximum of 1.110 dB. Now let's run this again. You see there are bursts in this black one. Those bursts in the black one is because somebody has started sending a Wi-Fi signal at 2.4 gigahertz. The important point is, whatever happens, for example here, the first level of cancellation and the second level of cancellation were going up and down because people were moving around, but at the end what we get, this curve comes very close to the noise level, and the fluctuation in the noise level, as I mentioned, is because of the Wi-Fi. Now my colleague runs it again, and please increase the time to maybe 20 seconds or 50 seconds. And now you see Okay, similar situation. So you see here, they are right on top of each other, and then there is a burst of Wi-Fi, burst of Wi-Fi. When there is no burst of Wi-Fi, the two are right on top of each other. And now okay, in any event, at the end, you see that our purple curve is very close to the thermal noise level. This system, in this demonstrations, we're sending maximum data rate that you can send over the bandwidth from A to B and simultaneously from B to A. It's important to point out the robustness of the system, that even if when we get bursts of Wi-Fi that are very strong signals, the system still doesn't, our full duplex system doesn't encounter errors. And next we will look at the error behavior. So now you have to run it again, and this other laptop will show the two curves. One is error rate and the other one is data rate. Now error rate, can you please put your, is it running? No, you have to run it. Okay, can you please put your hand in front of the antenna? One more. Yeah, you see, there are some error, but it went back to normal. Why the error are displayed with delay? Because these are happening at the microsecond time scale, and we are sampling them, slowing them down, and showing them at a speed that human eye can see. Now, I go back here. Can you run it again? And again, put your hand in front of the one of the antennas. Okay. So you see, when he put his hand in front of the antenna, okay, so you look at this red curve, how it jumped up, this one, but final cancellation is still at the noise level. What you see here is Wi-Fi. This is Wi-Fi. This is Wi-Fi. What matters is that our curve, the final outcome, and you see that we have cancellation in the range of 116, 111, 110, we reach to the thermal noise level, which means that there is no way that somebody can do better than this. We have obtained two completely clean line of communication over the same spectrum, transmitting at the same time. Thank you.